Hello. In this video, we will go over the difference between rectangles, squares, and rhombus. So this is geometry, special parallelograms, and yeah, we are definitely going to go over the difference between rectangles, squares, and rhombus. So what distinguish between like a rectangle or a rhombi? So yeah, let's start with the rhombus. So it is technically a parallelogram, but uh, yeah, so a rhombus is a parallelogram and it has all four sides that are congruent. So in the previous video, we talked about parallelograms, only parallel sides are congruent, but in a rhombus, all sides are congruent. So it's also similar to a square. A square has all sides that are congruent, but there's a difference. So in a rhombus, it's a parallelogram, right? All four sides are congruent. Opposite angles are congruent. So as you can see, this entire angle is congruent with this entire angle, and then this angle here is congruent with this angle. Uh, yeah, and then diagonals bisect each other. Uh, diagonals bisect angles. So, um, if you look carefully at the diagonals, they all form a 90-degree angle. Yes, so diagonals are perpendicular to each other. So in a rhombus, let's review a rhombus. So a rhombus is a parallelogram, and all sides are the same. Opposite angles are congruent. So this angle is congruent with this one, and then this angle is congruent with this one. And the diagonals, even though the diagonals aren't congruent itself, like you see that this side is only congruent with this side, and then this diagonal side is congruent with only this side, their angles form a 90-degree. Okay, so that's something you need to know. Uh, yeah. Oh yeah, diagonals are not congruent. We just went over that. Consecutive angles are supplementary. What does that mean? It means that if you add up this angle, it's called this angle one, and then if you add up to this angle, it's called this angle two. Angle one plus angle two is 180 degrees. Okay. So diagonals bisect each other, but doesn't mean they are equal to each other. We just went over that. Later on, other parallelograms, the diagonals are equal to each other, but in a rhombus, the diagonals aren't equal. They're not all equal to each other, but they do form a 90-degree. Okay, now let's talk about the other another special parallelogram. So a rectangle is technically a parallelogram. In a rectangle, all four sides are not congruent. Only opposite sides are congruent. So opposite parallel sides are congruent. So that means that this side is congruent with this side, and then this side is congruent with this side. Not all sides are congruent. But in a rectangle, all four angles are right angles. So in a rhombus, the opposite angles are congruent, but in a rectangle, all angles are congruent and all angles are 90 degrees, right? So all four angles are right angles in a rectangle. Diagonals are congruent. So in this time, the diagonals are congruent. So this diagonal side length is congruent with this side, and then this side is congruent with this side. But the angles are they don't say that the angles are congruent or 90 degree. Consecutive angles are supplementary, so so what they're just saying is if you add up this angle, it's called this angle one, and this angle two, angle one plus angle two is 180 degrees. Okay, so consecutive angles are definitely supplementary. So if you look at the bigger picture, this is one these are all parallelograms. You have a rhombus and a rectangle. So a square is a mixture of a rhombus and a rectangle, and it's still technically a parallelogram. Okay, square. I think this is probably the easiest one to remember because in a square it's technically a parallelogram, but in a square all four sides are congruent. So that's the same thing as a rectangle. I mean, not a rectangle, but what was the other one? The other shape, rhomb. No, the one above, the one. Oh no. Okay, so I was thinking, yes. So in a square, all sides are congruent. So if this is three, if this is three, this side must be three, and this side's three. All four angles are congruent. So uh, all four ang just like a rectangle, all four sides are 90 degrees. Diagonals bisect each other, and diagonals bisect angles, and diagonals are perpendicular to each other. So what other shape uh, where the diagonals are all the same? That would be I believe, a rectangle, right? So in a square, that's that. So if you look at the image, a square is technically a mixture of a rectangle and a rhombus. So in a square, the diagonals are all the same, and they form a 90 degree. Yep, diagonals are perpendicular to each other. Diagonals are congruent. Consecutive angles are supplementary. That's definitely true because if all angles are 90 degrees, this angle plus this angle is, let's call this angle one and two. Angle one plus angle two is 180 degrees. Supplementary, right? So every square is a rectangle and has all properties of both rectangles and a rhombus. So just look at, yeah, so a square is a parallelogram, which is a mixture of a rhombus and a rectangle. Okay, so now you know the special parallelograms. Let's talk about true or false questions. True or false? Any quadrilateral with two right angles is a rectangle. You think that's true? Any quadrilateral with two right angles is a rectangle. I think that might be false because in a rectangle, oops, all four sides are congruent, and then parallel sides are congruent, right? What's another technically quadrilateral? It would be this a trapezoid. We haven't gone over trapezoids, but we will talk about that. A trapezoid is technically quadrilateral, but this might be 90 degrees. These might be 90, but these are not 90 degrees. So I'm going to say false because of that trapezoid. Okay. Question two, any parallelogram with one right angle is a rectangle. Um, any parallelogram, so parallelogram could be uh with one right angle is a rectangle. So if let's look at a rectangle. A rectangle is technically a parallelogram, and it does have one right angle, so it's a rectangle. I'm going to say yes. That's definitely true. Yes. Question three says every parallelogram is a rhombus. So if you look at your image here, you have a parallelogram, and although here you have a rhombus, can't spell, and then you have a rhombus, and then you have a rectangle, and then a square is technically a mixture of both, right? So is a every parallelogram is a rhombus. Do you think that's true? Like, no, that's false, right? Just looking at this, every parallelogram is a rhombus. No, a parallelogram could be a square or a rectangle, so it's going to be false. What about question four? Every square is a rhombus? Uh, I think so. So if you go back to your where you have a parallelogram, mm, a rhombus could be this, and then a square is like a mixture of both. So is this true? Every square is a rhombus? Every square is a rhombus. Yes, because a square is a mixture of a rhombus and a rectangle. So yes, it is true. What about question five? Is every rectangle is a square? Um, every rectangle, no. Every rectangle is a square. I think that would be false. And the reason why is every square every square is a rectangle, but not every rectangle is a square. So yeah, false. Since every square is a rectangle, but not every rectangle is a square. Yes, so that's false. Question six. Every rhombus is an equal angular quadrilateral. Every rhombus is an equal angular quadrilateral. I think that's false. Remember in um, a quadrilateral can be a rhombus, it could be a square, it could be a rectangle, but it doesn't mean in a rhombus, not all sides, not all in a rhombus, right? The angles are not equal angular, right? So and this is every rhombus, no, this is false. Here you have a rhombus. It's technically a quadrilateral, but if you look at the angles, opposite angles are congruent. So this angle must be congruent with this, and then this angle must be congruent with this. And that's not equal angular. Equal angular means all angles are the same. So this is going to be false. Seven, every equilateral quadrilateral, every equilateral quadrilateral is a rhombus. Um, every equilateral quadrilateral is a rhombus. So what is a rhombus? It's a parallelogram with all sides are the same, right? So I think that is true, right? So every equilateral, so a rhombus would look like this, or it could look like this. Uh, in a rhombus, all the sides could be congruent, but the thing is, the angles aren't congruent. So every equilateral, yeah. So I'm gonna say false. I mean, true, true, true. Okay, let's move on to question 8. Question 8 says, if one angle of a rhombus is a right angle, then the rhombus is a rectangle. I think that is true. If one angle of a rhombus is a right angle, then the rhombus is a rectangle. Yeah, because in a rectangle, all angles are 90 degrees, right? Yeah, so I'm going to say true. Okay. Okay, question 9 says the diagonals of a rectangle are congruent and are perpendicular to each other. So is that true? The diagonals of a rectangle. So in a rectangle, not all sides are congruent, but they all form 90 degrees, right? So this side is congruent with this side, and then this side is congruent with this side. And what do we know about the diagonals? In a rectangle, the diagonals are all congruent. So here you have a diagonal like this. Uh, this side is congruent with this side, and this side is congruent with this side. So is this true? The diagonals of a rectangle are congruent and are perpendicular to each other. Okay, they may be congruent. The diagonals may be congruent. All of the diagonals may be all the same length, but it doesn't necessarily mean their angles form at 90. So I'm gonna say false. The only one that forms the diagonals form at 90 degrees are rhombus and a square. So rhombus and a square are the only one that forms the diagonals form at a 90 degree. Okay. Okay. Let's move on. Uh, example says find the indicated measure AB quadrilateral ABLE is a rhombus, and angle EAB is 60 degrees, and EA is 10 degrees. So let's fill in the blanks. So angle EAB, where is that located? EAB is EAB. It's this angle right here. So this is going to be 60 degrees. And length EA, what was that? This length right here is 10. Now, what do we know about a rhombus? If on the rhombus all side lengths are congruent, so if that's 10, that means this must be 10, and then this must be 10, this must be 10. Okay, now let's answer what they are asking. So angle Question A says, what is the angle of EAS? EAS is where's S? Oh, here's S right here, the midpoint. So EAS. Oh, so if EAB is 60, EAS must be 30, right? This little angle right here. So, because how do I know this is 30? Because this angle here is congruent with this angle. So it has to be 30 because 30 plus 30 is 60. Okay. What about angle ESA? ESA is this angle right here. And this is technically the degree of the diagonal. So what is the degrees of a diagonal of a rhombus? They are perpendicular. So they all form a 90 degrees. So that means angle ESA is going to be 90 degrees. What about C? Angle AES. AES. Yes. So this angle. So we know in a rhombus angles aren't all congruent, but we do know they are consecutive angles are s- are supplementary. So we know that if you add up this angle plus the 60, it should be 180. So what is angle AES? This small angle here. Well, I'm not sure, but this entire angle is called this x. So it would be 60 plus x, and we know that they are supplementary, so it equals 180. So if I subtract 60, it would be 20, right? 8 minus 6 is 20. ABS. Wait, ESA is 90. Wait, so if you look at this triangle right here, this is 90. This little angle here is 30. Do you see that it forms a triangle? So you could say 90 plus 30 plus x equals 180. So 90 plus 30 is 10, 11, 12, 120 plus x equals 180. Subtract 120. 180 minus 120 is 60. Okay, so angle AES is 60 because I saw a triangle right this you see this triangle right here. I know that the sum of a triangle adds up to 180, so angle AES is 60. Okay. What about D? Angle D says BAS. BAS. EAS. So EAS. I think that's going to be 30, right? Because this entire angle is 60, and then we know that this angle is congruent with this one, so this has to be 30. What about E? Angle ASB? ASB is what? It's a angle of the perpendicular, so shouldn't that be 90? this angle right here is perpendicular because if this is 90, this 90 is this has to be 90, this is all because the diagonals all form 90 degrees. What about F angle ABL? ABL. So ABL is this entire angle. And what is that? I think, well, I know that this angle, this entire angle is 60. And if you add up this angle, they're supplementary. So 60 plus x equals 180. And if you subtract 60 from both sides, you get 120. So angle ABL is 120 degrees. What about G, angle ALE? ALE. ALE. This angle right here. I think this is good. Not this small angle should be 30, right? Because you know that these two angles are congruent. So this, if this is 30, this should also be 30. So the letter G is angle ALE, just 30 degrees. What about H? What is the length of AB? Let's see, AB, we said that it should be 10 because in a rhombus, all side lengths are congruent. So it should be 10. What about the length of EB? I think that's also 10 because all side lengths of a rhombus are 10, are equal length. So length EB is 10. Okay, let's get this example. Um, it says find the indicated measure. PQRS is a rectangle. Angle SPT is 64 degrees. Side length SR is 20 and side length TQ is 12. So let's see. So here we have this rectangle PQRS. Angle SPT is 64. So SPT. I forgot there's a T right here. SPT is 64 degrees. SPT. So be careful. This is a box, which means this entire angle SPQ is 90, but angle SPT, this small angle here, is 64 degrees. And then side length SR is 20. SR is 20. Now be careful, this is a rectangle, so that doesn't mean all sides are congruent. So I kind of did another image to help find the other. So we said that if this is 64 and then this is a 90 degree, this small angle here should be 26 degrees, right? And you know how I got that? I just did 64 plus x equals 90. Okay, so that's 26. And yeah, so let's find letter A. What's the angle SPQ? SP. So it doesn't matter what image you use. SPQ. Oh, that's easy. SPQ. We said because of this has a small box symbol, that is 90 degrees. Okay. What about B? Angle TPQ. Uh, TPQ. This angle here, TPQ. Should that be? Oh, this small angle right here. TPQ. I thought it was this angle. So what is this angle? They're asking for this angle. We said that is 26. Letter C. What is the angle of PST? PST. Well, they're not asking for this entire angle. They just want PST, this small angle here. And what do you think that angle is going to be? I believe it's going to be 64. So PST is this angle, and yeah, so if you look at this, compare with this, we know that this is 64 and this is 26. That means this angle here is 64, and this angle here is 26 because of alternate interior and alternate exterior angles. And that means that PST, this angle here, should be 64. Okay, what about D? Angle STP. STP. So they want this angle here. So we're gonna have to use our triangle. So we know the sum of a triangle adds up to 180. So STP. So I don't know what this angle is. I'll call it X. I know that this angle is 64. And I know that this angle here is 64 because we just found that PST, 64 degrees. So um, it forms a triangle. So we know that 64 plus 64 plus X, which is STP is 180 because it forms a triangle. So when you do the algebra, STP is going to be 52. Okay, so that was D. What about E? What is the angle of TRQ? TRQ. Oh, TR. Here. It's this angle here. TR. This small angle, and this is going to be 64 because of alternate interior and alternate exterior. So, yes. And the letter E is TRQ, which is 64 degrees. Okay, let's move on to F. So letter F is angle TQP. TQ, TQP. So this angle right here. So it's a triangle, and I know that this angle is 26, and I also know that this angle, so it's TQ. So this angle right here. Wait, what we're doing letter, sorry, I was looking at the wrong letter, F. Angle TQP, so TQP. So this TQP, so I'm going to say this angle here. Um, yeah, it's going to be 26, right? Because of alternate, this angle here is congruent with this angle, and then this angle here is congruent with this angle because of alternate interior and alternate exterior. What about G? Angle STR? STR, so this angle right here. Well, I know it forms a triangle, so I know this angle is 26, and I also know that this is also 26, right? Because I know this is 64, so this must be 26. So if you add up this angle plus this angle plus this unknown angle, so that would be 26 plus 26 plus x, and it forms a triangle, so that adds up to 180. So that would be letter G is 128. H, what is the length of ST? ST is, where are you, ST? This length right here. Now, in a, this is a rectangle. In a rectangle, all sides are, the diagonals are all congruent, right? They tell us a few things. They tell us that length SR is 20, and then they also tell us that the length of TQ, this length here, is also 12. So that means that this diagonal should be 12, this is 12, and then this is 12. So the length of ST is 12. Okay, what about letter I, the length of SQ? So it's this length plus this length, so that's going to be 12 plus 12, which is 24. Okay. Letter J, what is the length of PT? Hmm, here's P, here's T. It's also a diagonal, so it should also be 12. What about the length of TR? TR, oh, that's also a diagonal, so that should be 12. What about the length of PR? Here's P, here's R, so it's this entire diagonal, so 12 plus 12 is 24. What about M, the length of PQ? P and Q, uh, PQ, so this length here. Well, it somehow forms a triangle. If you want to draw like a straight line, this forms a right triangle. We know that, so you have a right triangle, right? If I put like a little bisector, um, that doesn't help. So, uh, that's not gonna help. So what we could do is PQ, if you draw the image better, this is going to be the length Y, and then this is going to be 52 degrees. Wait, yeah, this length, we found that this angle here is 52, and we got to find out this length. Wait, uh, PQ is going to be, so I'm not talking, yeah, we're, oh, PQ is 20 because the length of SR is 20, so opposite, opposite parallel sides are congruent. So yeah. Okay, let's move on to the next example. So example says, in this example, XAVP is a square, and the length of XP is 10, and the length of VX is 10 radical 2. And we gotta find all these. So XP is 10, so this length here is 10. The length of VX is, here's VX. This entire length is 10 radical 2. Now it says a square, so I know that in a square, the angles are congruent and they form a 90s, right? So I kind of But a 45 here, a 45 there, because that forms 90. Yeah. So let's find the length of these. So what is the length of PV? Where is P and B? So this is a square, and a square, all side lengths are the same. So if this is 10, this is also 10. So PV is 10. What is the length of VA? It's a side length, and it should also be 10 because they're all the same. What about the length of PA? PA. So now it's talking about the diagonals. And what do we know about the diagonals of a square? The diagonals of a square, all sides are congruent and they all form a 90. So this side is congruent with this, and then they form a 90, all 90 degrees. Let's see. And this is 10. Um, do you see a triangle? I see a triangle. I see a right triangle right here. This whole thing is a right triangle. So if you draw the triangle, right, this is 10, this is a 90, this is 10. We got to find this length. That would be the length of, what is that? PA. So you can, because it's a right triangle, you definitely can use Pythagorean theorem. So you could do 10 squared plus 10 squared plus c squared, and that gives you 10 squared is 100 plus 100 plus c squared. 100 plus 100 is 200. Do the square root. And when you simplify this, you should get 10 radical 2. Okay, letter D, what is the length of XR? X and R. R is right in the middle. Wait, X. Oh, wait, hold on. Did I mess up? On letter C, they want to know the length of PA. PA. We didn't even have to do this because they actually tell us that the length of VX, where's VX, is 10 radical 2. So that means that this entire length is 10 radical 2. That was given. So that the length of PA is also 10 radical 2. What about the length of XR? So it's halfway. So I think you just divide it by 2. So 10 radical 2 divided by 2 gives you 5 radical 2, right? Letter E. What is the length of RA? Where's R and where's A? Um, RA. So, oh, that's this diagonal, and we said that all diagonals are congruent, so we said that this should be 5 radical 2 as well. Okay, letter F. What is the angle of PXA? PXA. It's this angle, and in a rectangle, I mean in a square, they all form a 90, so it's going to be 90 degrees. Letter G, angle RVA. 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 So it's just this small angle, and this is going to be 45 because this angle must be congruent to this angle, and they should all form a 90 degrees, so it has to be 45. What about the angle PRV? What is it? PRV. RV. This angle. This is remember, and this is the diagonals, and they are all perpendicular, so I'm going to say 90. And then letter I, what is the angle of ARX? ARX. It's also a di diagonal, so that's also going to be 90. Uh, okay, let's look at example 13. Given a rectangle ABCD, find the measure of angle 1 and angle 2. So in a rectangle, what do we know about a rectangle? Uh, all the angles should be add up, each angle should add up to equal to 90, right? So what should angle 1 and what should angle 2 be? So here's angle 1. Oops, why did I erase that? It's 1, and then this is an angle. This angle here is 7x. And what do I know? This angle 7x should equal to angle 2 because alternate interior and alternate exterior. And it was actually given that this one tick mark has one tick mark here, so that means they are correct. But that still isn't going to help. I think we need to figure out what x is, right? So we know that if you add up angle 1 and then this angle 7x, they should equal to 90. Uh, What is angle 1? Did you know angle 1 is congruent with this angle here, 2x minus 18, because alternate and exterior and alternate interior, and also because of these two tick marks, right? You see that this tick mark has two tick marks, that means they're congruent. So you could say angle 1 is equal to 2x minus 18, and then we can also say that angle 2 is congruent to 7x. And we also said that because this is a rectangle, if you add up angle 1 plus angle 2, it is equal to 108. I mean, it's going to equal to 90. So you could say 7x plus 2x minus 18 equals to, actually, if you add up, so this angle plus this angle, which is 90, is supplementary. So you could say equals 180. Yeah, that's much better. So let's do that. So what's 7x plus 2x? 9x. What is negative 18 plus 90? That is 72 equals 180 degrees. And then we're going to subtract 72. You get 9x equals to 108. Divide this by 9. You get 12. Now that's not our angle. They specifically said figure out angle 1 and angle 2. So we said that angle 1 is 2 times x, and we found x, which is 12, minus 18, which is 6 degrees. And let's find angle 2. Angle 2 is going to be 7 times x, so 7 times 12, which is 84 degrees. Okay, so that's how you do that problem. Last one. So given rhombus MNOP, find the perimeter. So what do we know about a rhombus? In a rhombus, all sides are congruent. And what do we know about the diagonals? Yeah, also the diagonals bisect each other and create a 90 degrees, but does that mean it's congruent? Let me go back to the notes. No, in a rhombus, the diagonals are not all congruent, but they do form a 90 degree. So this is a 90, this is a 90, this is a 90, right? So find the perimeter. So I gotta find this length, this length. Well, actually, I just gotta find this length because in a rhombus, all side lengths are congruent. So let's see here. So over here, maybe we can draw a triangle. Let's look at this. So let's look at this triangle right here. So that would be triangle. This one's a right triangle. This is P R O. And then this is going to be x plus 1. And then this length here is, uh, oh, I forgot. This was given x plus 2. So, yeah, so all of these sides are x plus 2, x plus 2, x plus 2. But we want to find, in order to find x, this side, we got to find x. So this is why I draw this triangle. So this length here is x plus 2. And then this length here is, I don't know what this length is, so I'll call it x. But we do know that this triangle forms a 90-degree because this perpendicular forms a 90-degree. Since it forms a 90-degree, you can use Pythagorean theorem. So you could say like x squared plus x plus 1 squared equals c squared, which is x plus 2 squared. So let's do that. What is x squared? X squared. What is x plus 1 squared? It's going to be x squared plus 2 times ab, so that's 2x plus b squared, which is 1. What is x plus 2 squared? That is x squared plus 2 times ab, so that's 4x plus b squared, which is 4. Okay, so what we'll do next is bring this up. So x squared plus x squared is 2x squared plus 2x plus 1. And then this is going to be x squared plus 4x plus 4. Our goal is to solve for x, so we got to get one side 0. So I'm going to subtract x squared, drop 4x, subtract 4. Right? So 2x squared minus x squared is x squared. 2x minus 4x is negative 2x. And then 1 minus 4 is negative 3 equals 0. And I'll factor this out. It's going to be x. Well, two numbers multiply negative 3 when added gives a negative 2, 3, and 1. And I'll do negative 3 and positive 1. When you actually solve for x, you get positive 3 and negative 1. I think you could exclude negative 1 because you can't have a negative length. So we found x, that's not our answer. They want to know the perimeter. So I need to find the length of NO. Because if I found that length, we know that we could just times that by 4. So NO is going to be x plus 2, and we found that x is 3 plus 2. So that's 5. So the entire length is going to be 4 times 5 is 20. So the perimeter is 20 units. Okay, we can stop here. So these are your special parallelograms. The next video will be on trapezoid properties. I will stop here.